So in preparing, in your last quiz, one of the things I like to do in classes is to find out what students are doing who are successful, and you usually can find a theme. So I was kind of surprised, actually. This is the first time I'm teaching where I have recorded videos. I haven't had that in the past. And it seems like everyone who did really well on the last quiz watched and rewatched the videos to understand what we did in class, which is really interesting because in our standard lecture, we don't have that. You don't get to re-watch it. So it's very interesting to me that, you know, when we stand up here as professors, we believe you're hanging on to our every word. Am I going to make you laugh till you cry with tears in your eyes? So, I mean, the belief is that, I mean, many professors talk amongst each other and they say, you know, I said this to the class 10 times and they still got it wrong. So maybe it's not just, our attention's not capable of taking all that information in an hour and thinking about it and digesting it. You have to kind of watch it again. So that's a clue. That was a common thread. It wasn't that they did tons of problems and they got ahead, which was very surprising to me. In the past, students in my classes who've done well in the proofwriting classes have done tons of problems. Doing the problems also helps because they educate you on a feel. It's not something that I can tell you. It's some kind of experience or a feel of how things get put together. So the more you see something or work with it, then the better you're going to get at it. So it's a combination, but the bottom line is I'd love to tell you they worked tons of problems because I'm a math professor. I love to see people work on problems. But the truth is it seems that just watching and imitating and looking at the video seems to be helping. So if you're not looking at that, that's important. One of the key properties that I've seen on the last quiz, and I saw people starting to do on this one, is doing things that I've never done on the videos. Like I've never had a fraction, ever, in any of the proofs that I've written. I've never written down a fraction, like A divided by B. So if you're doing that, you're going rogue, you're going on your own. You can't do that because you don't know that the result is going to be an integer. You're working with integers. So that's the reason you can't do that. But again, people who weren't doing that were also rewatching the videos and absorbing. So maybe that's a little bit easier than working tons of problems. But the math professor in me is going to tell you work tons of problems because it's fun. Let's see if we can rotate this around. Where do I do that? Rotate. It's probably hard to see, isn't it?
Yeah.
Let me see if I can magnify it. So I told you I'd show you some quizzes that, I mean, this is probably a little bit more similar to what I do. But what's interesting is people have different approaches in the class. And we have a group of experimentalists, people who just love working with numbers first and getting a feel for it and then packaging together their proof. So this is an example of a quiz where the first thing they did was not start to play with equations. That's what I do first, right? You see me put the nuggets together and start playing with the equations. That's not what this person did. They played around with numbers. So they could understand, like they were looking at the numbers and figuring out mechanistically how those numbers work together, and then they put the proof together after understanding the numbers. Perfectly fine approach. Again, all I look for is that the pieces of the proof are there, the raw skeleton that any professor would demand on a proof. Once those are there, I don't care how you do it. In fact, I value that you're doing it differently because I get sick of my own methods. I think it's cool when somebody's doing something different. So that's one example. See this one. So I like to call this person the front ender. They like to put a lot of front end work. They're writing way more than I write in class. They need to somehow see their words in writing. And they've done that as they went through. They're writing before they actually, if you notice, this is different than what I do in class, where I have the equation up and then start putting arrows and saying, I did this, I substituted this. And so I put the stuff up and then I do my editing. This person's front end, they put the words right in front of them. And for them, they might need to see it that way. They might actually need to read as they're writing and see that and say, this is what I'm doing at this step, and this is what I'm doing at this step. So again, here's an example of some different approach than what I've been doing. And this person's very thorough. Whoever this is, they're going to do really well if they ever take Dr. Persinski, because they made sure at every step of the way what they were doing was correct, and they went to the side and they checked with numbers. So they're extremely thorough. Again, you can see from my work that I'm more of a minimalist when it comes to writing proofs. So this is another example of a proof that looks different than the material I've been tossing out at you. And there's more. We've had the IKEA minimalist that's even more minimal than I am, but still has the structure there. There was a couple of them in here that looked like that, and they got full points. So I'm just looking for those pieces that are on the rubric. Once they're there, it's fine. So are there any questions about that?